Alright, so go ahead and title your notes the following. 201, simplifying rational expressions. And if you have not put your cell phones away, please put your cell phones away at this time. Cell phones, where they go, please. I need you guys focus during this lesson, so go ahead and put your cell phones away. Need you guys focused. Carpenter, good morning. Morning.
Luego, yo lo tengo que poner así, ya lo voy a guardar.
It's do not disturb.
Okay, good.
Yo lo tengo que poner así porque como tengo las notificaciones que me
Yeah. Honestly, everything's kind of the same level. Yeah. You can just leave it there. It's fine. Yeah, it's fine. Yeah, it's okay. As long as you know which one's yours. Yeah. Hey. You can just use the blue pouch, anywhere in the blue pouch. Thank you.
Pero pues no tengo que...
All right. Are you guys ready? Okay, let's begin. So, once again, the title of this is Simplifying Rational Expressions, and this is something that we learned in IM3, so you might see a lot of overlap as I teach the lesson today. One of the first things you guys should know is the vocabulary that we're going to be exposed to in this unit. So, what exactly is a rational number? Go ahead and write this down. A rational number is any number that can be written as a fraction. So let me write that down here. Once again, it's any number that can be written as a fraction. Okay. And I'll give you some examples right now. But for now, just go ahead and write this vocabulary down. Once again, a rational number is any number that can be written as a fraction. Now, if you think about it, all numbers are technically rational numbers, even whole numbers. Why do you guys think a whole number could be a rational number? Can a whole number be written as a fraction? Yes, and if it's written as a fraction, what is the denominator for a whole number? It's 1. Okay, good. So here are your examples of what a rational number looks like. We have something like 1/4. 1/4 is a rational number. We also have something more strange. What if I ask you to write like 101 divided by 8? That is also a rational number. And then something like a whole number 5 is also a rational number. And yeah, and the reason why is because it has a denominator of 1. So you're going to learn all about rational and irrational numbers. Once you guys get to college, they're going to talk about it a lot more. In our application, we just tend to think of rational numbers as just basically any number that just kind of exists. Irrational numbers, things like pi, or the one we taught you guys last year, the Euler's number, the letter E, how it stands for like 2.78. Those are irrational numbers because they go on forever, and they can't be expressed as a fraction. Like pi is 3.14, and it just goes on forever and ever and ever, right? So that's, irrational. Can't express it as a fraction. Anyway, So that is a rational number. Let's talk about a rational expression. What is a rational expression? Let's write this down. Rational expression. Okay. And a rational expression is a fraction. Kind of a word soup here, so let me write this down. A rational expression is a fraction in which the numerator or it could be both, and or denominator is a polynomial. Okay, so I'll explain what that means in a second. But just to rephrase or to restate what it says, a rational expression is a fraction in which the numerator and or denominator is a polynomial. So think about what makes a polynomial. A polynomial contains a variable. All right, for something to be considered a polynomial, it must contain a variable. So what this is saying is it basically is telling you that it's a fraction in which there are multiple variables in the top or multiple variables in the bottom. That's all it's saying. So some examples could be the following. Something like 1 over 3x is considered a rational expression because we have a variable in the denominator. We see an x underneath, right? Now, last year we saw more difficult rational expressions, something like x plus 1 over x squared minus 9. This is also an example of a rational expression because we have a polynomial on top and a polynomial underneath, right? We see variables in the numerator and we see variables in the denominator. And then one final example, something more challenging, kind of the stuff that you might see in this class, something like, I don't know, maybe x minus 3 over x squared plus 7x minus 14 or something like that. All right, where we are now seeing a trinomial and a binomial together. All right, trinomial 3 terms, binomial 2 terms. Okay, essentially, like I said, we're just seeing a lot of terms in the top and a lot of terms in the bottom, and of those terms, we happen to have variables. Okay. Okay, and then the last vocabulary or the last term that we're going to talk about is an excluded value. Hopefully, you remember this from last year. An excluded value is a value that makes your denominator 0. So we talked about this idea that you can't divide by 0 because it just doesn't make sense to divide by 0. Like if I wanted to throw a pizza party with you guys and then I divided my pizza evenly amongst 0 people, then how many slices would each person get if I'm dividing it with 0 people? See what I mean? Like then you're not even giving anyone anything. This doesn't make any sense. So this idea of dividing by 0, it's undefined, right? And so we don't want that. So that's what we have this term, excluded values. Excluded values we'll typically write as EV. EV, not for electric vehicle. EV is excluded value. And like I said, it's a value that makes your denominator 0. Okay. And once again, 0 means undefined. When you divide by 0, you get an undefined statement. Denominator can never equal 0. Okay. Sorry guys, I'm just trying to see how much space I have. Okay, let's take about 20 seconds or so to finish up wherever we're writing. And then I'm going to give you guys the main steps to solve this. Okay. Okay. So you guys ready for the next part? Yes. Okay. Let me give you guys the main steps that we have to take to solve or to simplify a rational expression. Let me go. Where do I want to go? Let me go down here. All right. So go ahead. Write this down. Steps to solve or steps to simplify. Your first step. Step one, how do we simplify? Well, step one is going to be the following. You are going to either do GCF or factor. Okay, GCF or factor. Your step two will be to identify excluded values. Identify excluded values. Notice how we're doing excluded values before we simplify. You can't simplify until you found your excluded values. Otherwise, you won't find all of them. Your last and final step is to simplify, which will often include canceling out terms. Okay. Typically, when we factor, we are looking for terms to cancel out. If there are this many number of x's in the numerator and this many number of x's in the denominator, some of them should cancel out. Okay. The goal is to get it to be as simplified or as reduced as possible. And the only way that's going to happen is when you break it down and cancel things out. Okay. I'm going to give you guys an example right now, and then you're going to work on one with your group. Okay. Are you guys done with this? Okay. All right. Here's your first example. We're going to do this one together, okay? So the first example we have is the following: 14x squared over 18x. So very straightforward. We have some x's on top, some x's underneath. 14 and we have 18. Okay. So according to our steps, the first thing we have to do is to factor or find the GCF. Now, what we're actually going to do is when we are looking for the GCF, we're actually looking to break this up into like each of its components. So let me show you what I mean. So 14 I can break up into what two numbers? What two numbers multiply to 14? 7 and 2. Okay, so I'm going to break up 14 into 7 times 2. And then what about x squared? What does x squared mean? X times x. So I'm going to break down x squared into x times x. So I have 7 times 2 times x times x. I have just kind of reduced or like simplified the top, right? And when I say simplify in this case, I mean like just broken it down into its parts. I'm going to do the same for 19 or for 18. What can I break off 18 into? What two numbers multiply to 18? 9 and 2. Now notice that we are getting a number that is the same. Okay, this is what we're looking for. We are looking for us to get similar numbers. Now we could have picked 6 and 3, and that would have been correct as well. But 6 and 3 wouldn't have given us any numbers with 7 and 2, like any numbers that are the same. So you kind of have to also pick the same kind of numbers so that you're able to cancel them out later on. We have 9 times 2 times x, and as you can tell, I'm kind of highlighting the stuff that we're going to get rid of, but we're not going to cross it out just yet because we have to find the excluded values. So I'm going to find the excluded values before I cancel everything out. That means I want to figure out what can x sort of not equal, otherwise my denominator is going to equal 0. So in this case, 9 times 2 times x, if I multiply 18, because this is really 18, if I multiply 18 by what number am I going to get 0? What can x not equal then? X cannot equal 0. Why? Because 18 times 0 is 0. So in our case, the excluded value is x equals 0. Now, since we don't want x to equal 0, you can cross it out like that. You can say we don't want x to equal 0, so you can draw like a slash through the equal sign, or you can just leave it like this. It doesn't matter. I'll accept both answers. Okay, so you can leave it as x equals 0, or you could say x and then put a slash through the equals and then 0, which is saying kind of like we don't want x to equal 0. That's what we're saying. All right, and then now that we have found the excluded value, we can go ahead and start, canceling out the terms that are the same. We can reduce 2 over 2 to 1 and x over x to 1, and we're left with 7x over 9. And that is a simplified final answer. 7x over 9. Okay. Question? It depends. In this case, because everything is being multiplied together, then yes, because anything times 0 is 0. But depending on what your denominator is, it might be like an actual number, like x can't equal 1, or x can't equal 7, or whatever. Typically, that type of stuff happens when you're factoring. If you were to use like the Xbox method or something, and then you have two binomials. Okay. All right. Let me give you guys one example to try on your own. It's gonna be just like this one. So let me come up with some numbers. Let me do that right here. Let's do 6x to the third power over think of a number. No, not 7. That's funny. Let me try 45. This is an example that you're trying out. From what I just did, now you're trying this one out. Okay, go ahead and give this a try. All right, so let's come back together. We have 6x to the third over 45x, and let's check in. How can I break this down? Raising your hand. What can I do with 6x to the third? How can I rewrite that? All right, hold on. Quiet down, please. Thank you. All right, let me go with Riley. 2 times 3 times what? 2 times 3 times x times x times x over, what about 45? 45x. Mena. 15 times 3 times x. You could have used 9 and 5, but the problem is then you would have to break down 9 into 3 times 3, which is fine, but you have to put it back together at the end. 3 times 5, you have to multiply back to 15. So anyway, we can find the excluded values for x right there. Because we are multiplying together, that means that x cannot equal what? What can x not equal? David Posada, your phone should be away. Kaylin, what's the excluded value? 0. Cell phone over there. No. Cell phone up there with everybody else. All right. So the excluded value is 0, and then what can I cancel out? I can cancel out the 3's, and I can cancel out one of the x's, and put together will give me 2x squared over 15 as the final answer. Okay, 2x squared over 15. Thumbs up if you got that. Good, good. All right, awesome. Okay, so that was an easy question. Now let's look at more pre-calc kind of stuff. All right, ready? Now this was like 7th grade math right here. Okay. All right, let me give you an IM3 type level question right here. All right, go ahead and write this down, please. We have the binomial x plus 8. It's okay. You can get anyone from the blue pouch. X plus 8 over x squared plus 5x minus 24. You get this? We're going to do it together. Okay. So we're doing this example together. Ready? Okay. Can I break this up? Can I break x plus 8 up? No. Why not? I'm adding them. If I'm adding them, I can't cancel anything out unless I have the same binomial on top with the same binomial on the bottom. It's gonna make sense in a while. So I can't do anything to the top, but I can do something to the bottom. It's a trinomial which we're gonna factor. Okay, it's a quadratic trinomial. We're gonna factor that. We're gonna be left with x plus 8 over. Let's figure out what we get from factoring this. I'm gonna throw this into a giant x. Negative 24 on top, 5 on the bottom. What two numbers multiply to negative 24 that add to positive 5? 8 and negative 3. Very good. So we have 8 and negative 3. So that means we're left with the binomials x plus 8 times x minus 3. Okay, go ahead and write this down, please. All right, you should have something that can cancel out, but we're not going to cancel it out just yet because we have to find the excluded values at this point. So we got to figure out what are the excluded values for x plus 8 and what is the excluded value for x minus 3. So if we were to set these equal to 0, we would have x plus 8 equals 0, which means x equals what? X equals negative 8 and x equals positive 3. So these are my EVs. Once again, these are my excluded values that I get from setting my denominator equal to 0 and solving for x. Now at this point, I can go ahead and cancel out whatever is the same on top and on bottom. In this case, you're canceling out the group. You're not canceling out the individual terms. You can't cross out an x with an x because you're not multiplying them together. You can cancel out the group of x plus 8 with a group of x plus 8. Okay, so keep that in mind. We can cancel out this group with this group, and so that's going to give me 1 over x minus 3 as my simplified answer. 1 over x minus 3 is going to be your simplified answer. Okay. All right. You guys ready for your example now? Okay. Let's try this out. Here is your example. Let me think of some numbers. X minus 1 over x squared um, minus what is this? X squared minus 4x minus 5. Is that factorable? I think it is. Okay, give it a try. I think it's factorable. Yeah, I think it's factorable. Try it out. It is? Cool. Oh, okay. It is factorable, no? Use a giant X. What? What's the problem? What? You gotta edit this video? What do you mean? No. Yes. What's the hiccup?
So we can't cancel anything out.
Hold on. Okay. Now it's factorable. Now it works. Keep in mind, I'm coming up with these like numbers like on the spot, so yeah. I think that works now. Change the x minus 1 on top to an x plus 1. That's gonna make more sense. I think after this one we'll do like 2 more examples, and then I want to give you the whole second hour of class to do your homework. Every day. What do you mean already? Huh? Yes. I'm gonna give you the second hour of class to do your homework. Well, I want to be generous. I want to give you some time. You're gonna get a break at 9:30. It's 9:11. Well, this is room 911. Okay, you guys finished? Yeah. Okay. Take 15 seconds to check in with the people around you. Okay, check your answers, please. 1 over x minus 5, and excluded values of -1 and +5. Right? All right. We're going to be kind of increasing the difficulty now. Okay. Okay, now we're talking college level pre-calculus. All right, quiet down, please. I'm gonna wait. Ready? Fig, you ready? All right. Girls in the back, we good? Ready? Okay, follow along, please, because this is going to be kind of long. Okay. This is your next example. Yes, question. Okay. 9x squared minus 15x minus 6. Plus 6, I mean, plus 6. Plus 6. 9x squared minus 15x plus 6 over 3x squared minus 7x plus 4. Okay. All right. You guys write this down yet? Can you keep solving? You're going to get an example on your own. Let's follow along for this one. Okay. So, listen up, everybody. We have two trinomials. And yes, we're going to factor. That's how we're going to solve this. We're going to factor both the top and the bottom. However, our approach is going to be a little bit different. We can't just throw the top into an Xbox method. I mean, you could, but you're going to do a lot more work than you have to. For the top, look at the coefficients. Look at the numbers themselves. We have 9, we have 15, and we have 6. What does 9, 15, and 6 have in common as a factor? A factor of 3. Very good. So we're going to actually take out a 3 from the top. If we take out a 3 from the top, then what are we left with as a trinomial? 3x squared minus what? Minus 5x plus 2. Very good. Yes. I'm sorry? What I did was I took the GCF of the top. Can we do the same for the bottom? Does 3, 7, and 4 have anything in common? No, they don't. Okay, so we're going to leave the bottom how it is. Let me do the following. Okay. I'm going to leave the bottom. I'm not going to rewrite it as a new expression over here, because now what I'm going to do is I'm going to take this and I'm going to factor that. Now we're going to factor that. Okay. Okay, so we're going to factor that with the Xbox method. Once again, we're factoring out only the highlighted trinomial. We're factoring that out in the Xbox method. So let's throw in the x first. It's the product of 3x squared and 2, which is going to give me 6x squared over negative 5x. So I'm looking for two terms that multiply to positive 6x squared and add to negative 5x. Negative 3 and negative 2x, yes? So we have negative 3x and we have negative 2x. Okay, question. We multiply the first and the last term. Okay. Okay. So now that we have that, we can throw this into the box. Once again, this is x box method, so you have to use the x and then the box. On the outside, well, actually no, we write the inside out. We start with the inside. We're going to solve the outside. So the inside is going to give you 3x squared and 2, and then the two numbers that we found was negative 3x and negative 2x right here. Okay. And if you're not sure where we're getting these terms from, let me show you. 3x squared is the first term in the trinomial. 2 is the last term in the trinomial. -2 and -3 we get from the x right here. Okay, so that's where we're getting these terms from. All right, we have to factor out these rows. So we go row by row and we factor it out. So from 3x squared and -3x, I can take a 3x out. And from -2x and 2, I can take a -2 out. That means this up here will be x minus 1. So the two binomials that we have now created from this is x minus 1 and 3x minus 2. Okay. So I'm going to write that down here. We have x minus 1 and 3x minus 2. Oops. We are forgetting something, and we have to put that back in. Did you guys know what? Notice what I'm forgetting? The 3 from the original factoring. That 3 we have to include. Okay. Don't forget to include that. I'll draw an arrow so you don't forget. So this is what we get from factoring the top. We're halfway done. We have to factor the bottom now. So we're going to repeat this, but now we're going to use the other trinomial. Are we good so far? Question? No? Okay. So let me go ahead and do the bottom now. So I'm going to go ahead and now we're going to factor this. Let me do that over here. Wait, let me make this pretty. I don't know, it's kind of ugly. Let me rearrange this so it's not so ugly. I'm just going to make new space, okay? Give me a second. All right, there it is. Okay. So now we're going to factor the bottom using the same method. And I'm actually going to give you about 2 minutes right now to do that on your own. Okay, I don't think you need me to walk you through that. All right, go ahead and take this time to do the bottom. Okay, so from the bottom, we get 3x minus 4 and x minus 1. So I'm going to rewrite it down here. So we had 3 times x minus 1, 3x minus 2, over 3x minus 4, x minus 1. Okay, we've just factored top and bottom. We're now going to find the EVs. So you have to find the EVs for this x and for this x right there before we cancel anything else out. Now, this one is easy because this one is x minus 1 equals 0, so x equals 1. That one is easy. This one's a little more challenging because that's 3x minus 4 equals 0. This is a two-step equation, which means that you are going to have to solve for x first by adding the 4, and then by dividing that by 3. Or, yeah, dividing it by 3. So that means that this x will equal 4/3. So these are your EVs. We have x equals 1 and x equals 4/3 as your excluded values. I know I'm kind of like all over the place. I'm sorry my notes aren't that pretty. I promise the notes that are going to be online, those are a lot nicer. Those are Ms. Rivera's notes. Anyway, so now that we have our EVs, we can go ahead and simplify this. You will notice that they both share an x minus 1. We're going to get rid of that. And our final answer will be the following. Our final answer will be 3 parentheses 3x minus 2 over 3x minus 4. This is what our final answer will look like. I'm not going to make you guys multiply the 3 back in. If you want to do that, you can. Okay? But you don't have to. Yes, question. Why am I not doing it to the top? To this? I can't cancel this one and this one out. Because this is a 2 and that's a 4. They're not the same. Yeah, this is different. This is the excluded value. So we only do that to the bottom. I didn't do it to the top. Excluded values are only done to the bottom. Yes. Okay, there is your final answer. Are there any questions or anything I can clarify for you guys before I let you start on your own? Yeah. Question related to the math? Yes. Bathroom, yes, you can go. Are there any questions related to the math that we just did? Okay, then yes. No. But thanks for asking. You're going to do one problem on your own. Once you do this problem and I check it, then you can get your cell phones and go on break. I lied. Okay, do this one and then we're going on break. Here's your final question. It's an easy one. No, it's not. Oh, this one's going to be fun. All right, this one's all yours. Bye-bye.